Today we're going to talk about section 3.7, which is about linear inequalities. We're going to look at how to graph a linear inequality, and then we are going to discuss how linear inequalities are relations, but they're not necessarily functions. So again, they're relations, but not functions, okay? So far in chapter 3, we've been looking at linear equations and their graphs. Okay, but in this section, we're going to see a little modification to what we've been going over, the linear equations. This is called the linear inequality. So remember, inequality symbols are less than, greater than, less than or equal to, greater or equal to, or not equal to. That's the inequality symbols. Linear inequalities are actually super easy to graph, as long as you understand how to graph linear equations, which was what 3.1 through 3.6 was about. Again, linear inequalities are not functions, but they are relations, because when you graph an inequality, you're saying x can be anything less than this, greater than this, less than or equal to this. So because you have so many options for x is repeated, which means that it can no longer be a function. So in order to graph a linear inequality, just treat it as an equation. And then once you have graphed the equation, you decide which portion of the plane represents the solution. So it's either greater than or less than the line, and then you shade it. So let's take a look at an example. Example 1. We'll start with wanting to graph 2x plus y is greater or equal to 5. So the first thing we want to do is consider this linear inequality as if it were a linear equation, and then we'll graph it. So if I were to graph this as an equation, I would want it to solve for y and put it into slope-intercept form. So remember, slope-intercept form is this y equals mx plus b. Because once I have that, I can graph it using my y-intercept and my slope. So I want to take this equation and make it look like my slope-intercept formula. So I'm going to solve for y. So I'm going to subtract 2x from both sides. So now I have y is greater than equal to negative 2x plus 5. So now I have what looks like a slope-intercept form. So I have a slope of negative 2. My b value is 5, which means my y-intercept is at 0, 5, which means I can now graph this. So I'm going to go ahead and make a coordinate plane. I'm going to plot my y-intercept. So 0, 5. All right, and then I'm going to use my slope. My slope is negative 2. So remember, slope is rise over run. So I'm going to rise negative 2, so which means I'm going to go down, and then I'm going to run 1. So rise negative 2, run 1. That's my first point. And then I'll go opposite. So up 2 and then to the left 1. That's my second point. So since my equation is greater or equal to this line, that means that it could be equal to the line. So I'm going to go ahead and when I sketch the line, I want to make it a solid line because it could be equal to the line, right? It could be equal to the line. That's what this piece means here. It could be equal to the line. So now I have to decide the shading. Do I shade above it or below it? Well, since it's greater than or equal to, that means that it's everything above this line. So I'm going to shade everything above the line. I'm going to shade everything here. And that becomes my solution. All right, I'll do one more example. So this one says graph R and it gives us a set, all the ordered pairs, x's and y's, such that 4x minus 3y is greater than 6. So again, I want to treat this as an equation and put it into slope-intercept form and then graph that line. So I'm going to go ahead and start with subtracting 4x from both sides. So now I have negative 3y is greater than negative 4x plus 6. Then I'm going to divide everything by negative 3. And remember, when you multiply or divide by a negative number, your inequality flips. So negative 3 divided by negative 3 is 1. So I have y. And then negative 4 over negative 3 actually becomes positive 4 over 3. And then 6 divided by negative 3 is going to become negative 2. So now I have this. So my m is 4 over 3. My b is negative 2, which means my y-intercept is 0, negative 2. So when I go to graph this, I want to graph my y-intercept, 0, negative 2. And then I want to use my slope to figure out 2 more points. So my slope is 4 over 3. So I'm going to rise 4 and run 3. So rise 4, 1, 2, 3, 4. And then run 3. 1, 2, 1, 2, 3. So here's my first point. Then I'll go opposite. So down 4. 1, 2, 3, 4, and then to the left 3. Here's my second point. So when I connect this, I have to consider my solution is supposed to be less than the line, but not equal to the line. So I don't want to just draw a line, because if I connect the dots with a solid line, that means that my solution could be on the line, and that's not true. My solution has to be only less than the line. So when I sketch my line, I want to use a dotted line to show that it's not technically on, my solution's not on the line, it's just less than the line. And so when I shade, I want to shade below the line. So I'm shading all of this area. All right, that is all for this lesson. Go ahead and try some problems on your own.